Good morning, all. So,
Morning.
my screen is visible, guys.
Yes.
Yes.
Okay. So, hi, my name is Gaurav and I'm from Network Kings. Okay. So, for this batch, we have a trainer, Rahul, who have almost 15 plus year experience in industry. He worked on all Cisco things. Okay. So, I'll give you a small introduction about this program, how we are gonna how we are gonna deliver this entire program for the next 6 months. Okay. So, you can see there are two options available in this. The one option, the people who is interested for a Cisco track, they can go for CCNA, CCNP, NRC, and a Cisco ASA firewall. This is the one track. And parallelly, we have another track which is a CCNA, CCNP, NRC, and the difference is a Palo Alto firewall. Okay. So these two programs we are going to deliver in next 6 months. So when I'm talking about CCNA, in under the CCNA, we are going to discuss about the networking fundamentals, LAN switch protocols, IPv4, IPv6 network services, basic security, and wireless fundamental. Okay. When I'm talking about CCNP, NRC is very advanced course. Okay, because the prerequisite to understand CCNP, NRC is CCNA. This is the reason we are going to start from CCNA only. When I'm talking about CCNP and RC, it's purely focused on routing. So we are going to discuss about the network architect. We are going to discuss about the major protocols like OSPF, IGRP, BGP, and some of the part of MPLS also. Okay. And layer 3 troubleshootings, VPN technologies, and automation and network services. These all is part of our CCNP and RC. So the first two modules, CCNA and CCNP and RC, it's going to be a 50-50 hours. We can extend for 10 hours extra also based out our audience, how they're learning the things. Okay. And the last module is for Cisco, which is ASA firewall. And if somebody wants to learn a Palo Alto is a rank one firewall as of now in terms of security. When I'm talking about Palo Alto is famous for app ID, user ID, content ID. So this is something like you're going to learn different from other firewalls. When I'm talking about Cisco, or when I'm talking about Fortinet, when I'm talking about Palo Alto. So Palo Alto is a leading market security devices, what Palo Alto is providing. Okay. So with the help of this master program, you can aim these career path basically as a network engineer, or you can go for Cisco TAC also because you're learning seats entirely end-to-end routing, switching, and security. Okay, and if in case you're choosing a plan two is basically again CCN CCNPs remain same, but yes, additionally you're learning a one different vendor. Different vendor means when you're gonna going for the interviews and you're mentioning one side in your resume that you have a knowledge on all the Cisco things, and somebody is mentioning that I have a Cisco as well as a Palo Alto, you're getting a more preference as comparison to one vendor knowledge. So we always prefer to have a knowledge on multi-vendor technologies. Okay. So thank you so much, guys. And Rahul, over to you. Now we'll start with the day one for CCNA.
Sure, Gaurav. Thank you so much. Good morning, everyone. This is Rahul. So I've been training from past 15 years. So my expertise lies in routing, switching, Palo Alto, uh, and also the VPNs, etc. So I've been in this industry for quite a while. So let me actually first share my screen. Hang on. Let me know when you guys can see my screen. Is it visible?
Yes, sir, it's visible.
Okay. So, as Gaurav said, he introduced the hierarchy to you. So, how is it starting off? So, how is the network knowledge starting off? So, basically, CCNA is the foundation, right? So, CCNA, it all starts with CCNA. Now, as in we proceed with CCNA, CCNA actually gives you a little bit of knowledge, the basics, the building blocks, the foundation, right? It tells you where you are. CCNP actually deepens your knowledge, where you can actually design the network, manage it, maintain it, and CCIE, and with the help of Palo Alto, right? So Palo Alto, as he said, it's one of the leading industrial firewall. Along with that, you can actually be a good network architect or a network designer. It all starts here, CCNA. Now, before starting with CCNA, I would like to just introduce the syllabus to you guys. So this is what we have in our syllabus. Now, when you see the first part says Introduction to OSI model, which is basically from the network fundamentals. So network fundamentals actually tells what is the basic rules of networking. What are the things that has to be followed before entering into networking? So network fundamentals are those topics which tells you which are the mandatory concepts or the rules in networking or the basics in networking upon which you try to build your network. Now, coming to the second part is the network access. Now, when I say network access, it is as simple as how are you trying to access the network? I know you are a user with a computer in front of you. How are you trying to use the network? With the help of a switch, right? Usually, computers are not connected to different computers. Different computers are connected together with the help of a switch. So network access is that portion where you will learn all about switching, the rules of switching, how the switch behaves, how does the different network reacts with the switches being around it. That is what we will learn in network access. Everything about switching. Not only about switching, switch, as you know, is a hardware device which is connected physically through cables. We'll also learn about wireless, which is again in the part of network access. Wireless also has a kind of a switch which is called as access points, just like the Wi-Fi routers that you use at your houses. That also comes in network access portion. Now, the third part is IP connectivity. IP connectivity is where we are going to learn about the IP addresses. Usually, we know that nowadays every device is having an IP address. Now, which all devices can be provided with an IP address? And having an IP address, is it sufficient for two devices to communicate? And which one is called as a network? How can you separate two networks from each other? Or when you call as a big network, how those big networks can be cut into many different networks. All those you will see in IP connectivity. So basically, IP connectivity also talks about something called as routers or something called as routing. You will learn about it. Maybe you are currently not aware of what is a switch, what is a router, what is routing. You're not aware of all that. I know, I understand. So this part, I just want to tell you that this part involves only about routing. So you can be little confident that you are learning about each device in each section thoroughly. So there is no mix and match. Each device is given priority in every section, right? Then we talk about IP services, which are nothing but, different kinds of services provided or different protocols which actually help us in creating services. Then we have IPv6. Anyways, just like IPv4 version 4, we have version 6. We'll learn about that. Then we have some security fundamentals. So when we have reachability in our network from one point to the other, right? Let's say in a company, in an organization, we are able to reach from one corner of the building to the other corner. When I say we are able to reach means we are able to talk, communicate. How to restrict them? How to restrict some part of the communication? Those will be covered in security fundamentals, right? Apart from that, how to secure a port? What is called as snooping? Everything will be under this section that we will be learning. Now, these are some of the management tools which actually help us to manage the network. Now, we have different devices. So, for example, just in layman terms, right? In normal human terms, we have so many devices, how to manage them, how to group them together and, configure them in one go. Or let's say you have so many things at home. Who manages what? Who takes care of what? That is defined in network management. Network design. So after learning the behavior of every device, right? You have learned that, okay, router behaves so and so. Switches behave like this. Firewalls behave like this. Now it is the time to understand about the network design. Then using these components, how do I design my network? Because I know their behavior. This router looks good at this point, at the entry point in the network. This router looks good at the exit point in the network. So based on that, you will learn about the network design. How should a design be? The last portion is nothing but your automation and programmability. So everything cannot be configured. So let's say there are so many hundreds, thousands of devices. Everything cannot be managed by humans. At some point, right, you need some devices or some scripts, some automation, which actually takes care of all this. We need some scripts which run the configurations for us. What configurations? What configurations are there? You will learn. Once you know about basic configurations of routers, switches, or whatever the network, you will know what is a configuration. You will know why is it required for some of the scripts or some of the automated processes to pitch in to do our work. You will learn about it, right? This is about actually the syllabus that we have for CCNA. Now this, as he said, it will take about 50 hours, 50 to 60 hours to cover all these topics, right? We will be going into each and every section in a detailed way, and we will be having the labs for all the section. So network fundamentals is something about the basics that you need to learn. Now, this also has some part of demonstration, like demonstration in the sense, so I tell you, this is how it works. Then I will have to show you that, and you will have to witness if whatever I told you is correct, right? Now, this part, network access, involves all the labs. right? We have labs for each and every section for network access. We have labs for every concepts that we see under IP connectivity, where
And
there
guys,
is
one more
explanation.
thing, sorry to interrupt, Rahul. And
Yes,
guys,
sir.
this lab we are providing, networking is providing a lab that, like, if in case you are a part of our master program, not standalone only for CCNA, if you're a part of our master program like a CCNA, CCNP, and firewall, so you don't need to install anything on your laptop. The lab is provided by networking. It's simply you need a laptop and one browser. I'll give you link, user ID and password. 24/7 you can practice. And a big to big topologies, multiple router, multiple switch, different scenarios as per the industry requirements. Like, thank you. Rahul, continue.
Yeah, right. So yeah, as again, these labs, these labs will be just be done using a link, right? The labs are like this, right? We just have links for them. You'll get your own links for the labs, right? And once you get the link, you can start accessing these labs. And these labs would have been, and each section of this unit 2 would be demonstrated in the lab as well. Again, IP connectivity. I show you how the IP connectivity works, how a router works, how a switch works, how the combination of them works, right? And also we have labs for all these sections, right? So there are few sections where we don't need a lab, right? For example, the network design. I can tell you how we design the network by designing them, right? And also coming to automation and programmability. There is no lab in automation and programmability because CCNA syllabus has just introduced them for you guys just to know the basics of automation and programmability in the CCNA part. They don't want you to configure anything or they don't want you to write any scripts. They just want you to understand, or the Cisco just wants you to understand how this basics of this works. They don't want you to program anything using, any scripts or something. They just want you to understand how the AI works, how the ML works, right? Here, this portion you would not have any lab. Otherwise, we do have labs for all of them. If somebody was looking for something called as lab, how it works, or which part we have labs, this is how it works. Okay. Now, having that said, I hope there are no questions about it. But if you have any questions, you can ask me, not a problem. Right? Now, I will be moving on to a little introduction about our networking devices. Since we are going to start about CCNA, right? It is important. It is actually a must, I would say, for you to know about some networking devices. Obviously, because whenever we talk about, some pharmacy, some doctors, you need to know how you need to know different instruments, different, gadgets that we are using in the medical field. Similarly, when we are talking about networking, there are some networking devices that we need to know that acts as our basics in our networking, right? So everybody know this is a PC, right? This is a PC. We use them for networking. Now, what does this device do? This device actually generates the information. When I say generate, what do you, I mean, how does it generate an information? Let's say this guy wants to go to google.com, right? So when he says google.com, or let's say he wants to see the live score, he goes to the search engine, says live score. Of course, he generated a data. Now, where that data has to go? to the server. Which server? Google server. So I would call this, or the PC is called as a generator of information. Now, are we telling this PC how to generate the information? No, we are not doing that. As network engineers, we need to make sure we are not telling the PC how to generate the data, how to change the data, or how to receive the data. We are not telling them. We are making sure that the data from the client reaches the server. There are lots of networking devices in between. We need to make sure the data travels and reaches the server. That is what is our responsibility. We don't have to, edit anything, alter anything here. He is the generator, he is the processor. So server will process the information, fetch a reply as well. The reply also should reach the source machine, whichever triggered a request. We need to make sure of this connectivity in between. Now, in between, what is that? There are different types of network devices. We will discuss one by one. Right? Now, I told you that this is a PC. Of course, when you know the age when the PCs were invented, having a single PC and making sure, let's say, these are the records or these are the stocks that I received. It was easy to maintain on PC. On PC, I will write down, instead of my files, writing in files, this might get lost. So I will write it in PC. Now, okay, everything was going cool with the PCs, but what is the use? Only this user is able to store that information in this PC. Now, if he goes to a new factory or a branch of his own, there again, he is not able to see what is the stock that he has here. He is not able to share this information with any other branch. So they came to know the importance of sharing that information from one end to the other. So if we have some information in one PC, of course, we need to share that. Otherwise, what is the use of having that information in store in one PC? So what they did, they decided, okay, I think we need to connect from one PC to another. Let's buy another PC. So what they thought, okay, buying another PC and having that same record in this PC also. Then they discovered floppy disks, CD, So the same information is replicated on the other end as well to share the information, right? Now, whenever you have PCs, you can see that there is only a port in the PC, just one port. If the PCs had only one port, then only one PC can talk to the other. One system can talk to the other. Not more than two machines can speak to each other. They needed a centralized device for making these group of computers talk to each other. So they found out a centralized box. They planned that let's all connect to this box and let this box guide from source to destination. Now, having this centralized thing in between is helping us to communicate between 5 devices or even more than that. Now I don't have to, manufacture many ports on this PC. or system. I don't have to manufacture 40 to 50 ports on this computer. I just have to concentrate on putting so many ports on this centralized box. In the first generation, the centralized box was called as a hub. This was called as a hub. In the first generation, the first invention was a hub. It was called as a hub. Now, what happened to hub? This was a great invention at that point of time, right? Now, let's give some names to these species. Let's suppose that A wants to talk to D. Of course, you know that this is a wire connected from PC to hub. This is a wire connected to
So,
PC.
Rahul sir, I'm
Yeah, yeah.
sorry for the interrupting,
Yeah,
but
sure, go ahead.
I could not understand the topic we are now we are discussing on.
It's just the basic networking devices that we have.
Okay,
So, for example, we have hub, switch, routers, firewalls. These are the different networking devices that we use on a day-to-day basis in our networking industry. So I'm just trying to give you an introduction about those devices.
okay. So can we have the communication in Hindi as well?
In Hindi?
Yes.
Jitendra, this is going to be an English batch because
Okay.
Rahul from South, so he cannot speak in Hindi.
So,
In Hindi, we have a batch from 27th March.
okay. Thanks for the update.
Yeah, thank you.
Okay, Rahul.
Continue.
Thank you.
All right. Now, this is again a cable connected from hub to different machines. Now, the behavior of the hub I'm talking about. The hub was designed in such a way that whenever a traffic, so let's say this PC wanted to talk to this guy, A wants to talk to D. Whenever it sends a message, obviously through the cable, it used to go to the hub. The behavior of hub was in such a way that whenever it receives any information on one port, any port, let it be, any port, okay? The hub was designed in such a way that if it came on port number 1, it will forward it on port number 2 also, 3 also, 4 also, 5 and 6. All of them. This is how the hub was designed. Initially, it was okay. Why it was okay? Because there were very lesser number of computers. It did not matter much. But as and when the computers started growing or the number of devices connecting to the hub increased, then they saw something called as a delay. Why? Because it was going to everybody. The information coming in was going to everybody. Now, only the person who was in that. So, for example, whenever you write a letter, I would say, whenever you write a letter, you always write the from address, the to address. Similarly, whenever a computer generates a data, it always writes from who is the generator of this information and who it wants to send to. It wants to go from A to D. Now, the hub, due to the behavior of the hub, every device actually got that. But what does all others do? They drop the information. They drop the information because it is not for me. But only D responds, saying that, yes, I am D. I got the information. Then if it has any reply for A, it responds. But everybody used to get the information. That is for sure, if the hub is connected, right? That was kind of a disadvantage. Why disadvantage? Because there is lack of security as well. We thought that we are sending to only intended devices, but everybody else is getting the information, first thing. Then the second thing, I want to send an information from A to D. This letter or information from A to D. It has to only go like this. But it is going to this guy, this guy, this guy, this guy. What is the problem with that? The problem is, let's say that at the same time, even F wants to communicate with E. But you see, the wire is already filled up with this information which A has sent to D. That information has occupied this wire, or the cable. So at the same time, even F wants to communicate with E, it is not possible, or it is finding some delay. As and when the number of devices increased, they found this problem. This is not going to happen. We are not going to use hub anymore. There needs to be a new device, centralized device. There should be a different device, or the behavior of that device has to change, right? Then they introduced something called as switch, or I mean, in between many devices came, but we'll come to the actual thing that we are using. Then we saw something called as a switch, which we are using even today. Now, the switch is actually an intelligent device. When I say intelligent device, it was designed in such a way. Let's say this is port number 1, port number 2, 3, 4, 5. Now, what does the switch do? What the switch does is, at first, when A wants to send some information, some letter to the source, to the destination D, the switch does not know whenever the information comes to switch reads this information and also studies what is the source, what is the destination. Now, if it does not know the destination, first it will concentrate on the source, right? On my port number 1, something is coming to me. Some information is being sent to my port number 1. Okay, and who is sending the information? Somebody called as A. So it creates own table. On port number 1, somebody called as A is connected because he is trying to send an information to D. Now it doesn't know where is D, so it sends it to everyone. Now this D only responds to that message saying that, yes, I am D, this is my reply. Then it actually fills the table. Port number 4 of me is connected to D, right? Port number 1 is connected to A. Port number 4 is connected to D. How it knows? When D replies, it comes to know, okay, port number 4 is connected to D. Now let's say there is another information from A. It wants to go to D. Now, whenever the information is sent to the switch again on port number 1, it sees what is the source. Source is A. Let me put it in my table. Oh, it is already in my table. I don't need to worry about that. Now, what is the destination? It wants to go to D. Let me check my table if it is in my table. Yes, D is connected to port number 4. So it only forwards to port number 4. Now, this is how the switch behaves. It actually learns from the flowing traffic, right? The device was designed in such a way that it was asked to learn from the flowing traffic. So it makes a table of its own. It tries to learn what is the traffic coming from port 1 and where is it coming from and where does it want to go to. But if it does not have any information in this table, then it sends to everybody, means every port of it. Right? So to be precise, let's say second time A wants to talk to B. The information comes from PC to switch. Switch will check. Do I know where is B? There is no information in the table. It will forward to everybody. Right? So that is how the switch behaves. If it doesn't know something, how can I say the switch doesn't know something? Because there is no information in the table. If it doesn't know something in the table, then it forwards to everybody. If it has in the table, then it only sends to that person. Based on that, we have three types of communication. Based on that, on what I said, the communication is divided into three types. First one is unicast. Second one is multicast. I think many of you would be knowing this. Third one is broadcast. These are the three types of communication that we have. Now, what is unicast? Unicast is nothing but one person talking to another. Let's say A is talking to B, or A is talking to D. Right? This is nothing but unicast communication. Just like here, when A wants to talk to D, unicast communication. Multicast. Multicast is when A wants to talk to B, D, and E. There are many, right? It only wants to talk to B, D, and E. Multicast. It wants to only talk to a group, just like how I am talking to only the CCNA batch, March 2026. Means I get only the list of few people. So it is a group. I am I am only talking to somebody in the meeting. Let's say if I'm only talking to Gaurav, it is a unicast. If I am talking to all you guys in the group, that is a multicast. Now, I just go out and keep shouting the information. Everybody can hear it. That is called as a broadcast. Right? The example of unicast communication is one-to-one. Right? For example, here, A talking to only D, one-to-one, or the switch only sending it to D, one-to-one, unicast. The example of multicast is, for example, you can take the example of a multicast as a radio station, maybe, because only the 98.5 or 3, I don't know the frequency, only the frequency tuned users will get that particular, will be able to hear that particular song, nobody else. So it is one to a group of people. Source is nothing but your radio station. Listeners are your destination. Group of people. So source is sending to only a group of people. That is a multicast. What is a broadcast? In the railway station, the announcement everybody can hear. Or if there is a huge thunder, everybody can hear. That is a broadcast, right? These are the three types of communication we have. Now let's put that here. Let's put that communication concept here. Now, whenever A wants to send a particular thing to D, A will send it to the switch. Okay, because it is connected to the switch. Now, depending upon whether it has an entry, now switch will immediately refer to the table. Now, what is this table? It is the brain of the switch. Without this table, switch cannot take action. Switch will refer to this table. Do I have something called as D? Yes, it is connected on port number 4. Now, switch will send a unicast message out of port number 4 because it has an entry in the table. Now, let's say A wants to talk to B. It will send an information to the switch. The switch now refers to the table again. Do I have something called as a B? Now, there is no B. What the switch will do is it will broadcast out of every port. This is called as a broadcast. It will send the broadcast, means the same message, the same information, the same letter is sent out of every port. That is called as a broadcast. Whatever port on the switch it has, it will send out of every other port. Right? That is called as a broadcast communication. This is how our switch works. Right? So nowadays we are using something called as a switch. We moved on from hub to the switch because we had some disadvantages with the hub. So we moved on to the switch. Now the switch is the, even used in today's regular. That's about how a switch works. And I don't want to get into the technicalities as of now. What is this table called as? So for the name, I can say it is a MAC address table, right? But I don't want to get into something called as what is a MAC address and all that stuff. Maybe I can introduce what is a MAC address if I have time today at the end of this session. But right now, let's not get into this. Okay, just the working. I'm just explaining the working of different devices. The third device that we have is a router. Right? Now, what is a router? Router is a device which actually routes the packet. So, for example, when I say packet, right? Packet is nothing but the information or a letter that some source has written to some destination. Right? Now, when I say router, let's take a simple topology. This is a
सॉरी सर
router.
फॉर इंटरप्ट सर सर राउटर आप वापस से करवा सकते हो मतलब पहले से थोड़ा पैकेट वाला समझ नहीं आया
Sorry, repeat that again.
राउटर राउटर once more time sir packet and all I cannot understand
Is it only me who is facing problems in hearing him, or is
Sir,
everybody?
he's just
no, sir,
asking you
I
to,
am
can you
very
repeat
properly
the routing part once again?
Everyone have a problem.
It was a confusion again. Again, please. Somebody, anyone?
So he was asking, can you just repeat the router part once again?
Yeah, I'm just starting the router. I'm just starting about the router.
thank you sir
Okay. So let's say this is a router. Okay. And switches are connected to the router. And you know that by now, computers are connected to the switches. Right. Now, there is something called as a network. Right? We will learn about the networks for sure. But there is something called as a network. Now, for example, to be talking in layman terms, so for example, you are in the zip code called as 30,001. Let's say 30,501. You are in the zip code 46,501. I mean, area I'm talking about. You are in this area, the other guy is in this area. You both want to communicate with each other. Now, this area has many houses with all the door numbers given. This area also has many houses with all the door numbers. Now, they are not in the same area. The source. So, for example, this guy who is in this house wants to talk to this guy who is in this house. They are not in the same area. They are in a different area. Right? Now, the one who communicates the information from one area to another is called as a router. Right? Router is something that communicates from one area to another. Or in terms of network, we have different network attached here. For
Okay,
example, sorry? Nitin, you said something?
No, Rahul, I think it's by mistake.
Okay, okay. All right. Now, we call this as in networking, we identify the devices by IP address, right? Whenever I say IP address, let's say 1111, 1112, this computer is assigned with 1113. This is 2221. So I give the IP address like this in this format. Why IP address have to be given in this format, we will discuss. But for now, understand that one dot network. Now, these computers are in one dot network. These computers are in two dot network. Now, if a information has to be delivered, so let's say this computer generates an information. So if this computer generates the information, the source will be always 1.1.1.1. Why? Because this computer generated an information. What is the IP address of this computer? 1111. So that will be the source. Where does this information need to reach to? Let's say 2221. Now here, this information should go out of the network, right? This information has to go to a destination which is out of the network. At that particular point, routers are very necessary. Routers are very important. Why? Because the information has to be routed. We call it as routed in networking terms. But in layman terms, I can tell you the information has to travel from one network to the other. So we need a router in between. So by the definition, I can tell you a router is a device which routes the information between different networks. Okay. So how does a router work? Just like a switch, it maintains some table, right? What is the table that it maintains? It maintains, let's say that it is configured with 100 here, 222, 100 here. Let's say an interface name. We'll talk about the interface. It maintains a table called as routing table. Based on the routing table, the router will take routing decisions. You are going to see that, right? Now, it maintains a table saying that what network is connected to what interface. What network is connected to what interface. So when an information comes to the router on this particular port, F00, which is this one, it immediately refers to the table. Now it sees, the router sees what is the source, what is the destination. Destination is 2221. It immediately refers to the table. Where is 222 network connected? Oh, it is connected on F0 bar 0. Let me send the packet. Oh, 222 is on F0 bar 1. Okay. It refers to the table. It comes to know that, okay, 222 network is connected on F0 bar 1. It will send the packet out of this one or the information out of this port. So basically, router and switch both work on the table that they are created by their own. They will learn the networks as and when you assign. So let's say we assign an IP address to this interface. They will put that in a table saying that my left hand is connected to so and so network, right hand is connected to so and so network. My F00 is connected to so and so network. F01 is connected to so and so network. It makes a table of their own. By creating the table of their own, they use their intelligence then in forwarding or discarding the information. That is the job of a router. So basically, in short, I can say that router is used for routing the information from one network to the other. Okay, that is as simple as an explanation it could be. Okay, now moving on, maybe we can talk about the next networking device. Let's say a firewall. I think everybody knows about firewall nowadays, right? Only the technicalities you would not know, but I think what it does, why it is used, you would definitely be aware of it. Now, firewall is something I would say is something which is used to restrict. Now, for example, when I say router is connected to so and so, router creates its own table, right? Saying that my so and so networks 1110 network is connected to F0 bar 0. 2220 network is connected to F1/0. Now again, when the packet comes, the same information comes to the router. Okay, it will check what is the destination 2221. Okay, 2221. Let me refer to the table. 222 network is connected to F1/0. It will forward the information. So basically, there is no stoppage. But firewall is a device which checks. You can mention anything on the firewall. So based on the IP address also, you can create some rules. So firewall is a device which provides access to the destination. It provides access to the destination only after checking some rules. If there is a rule in the firewall that, okay, that particular network can be accessed, then it will allow us. Otherwise, it will not allow us to go to that particular destination. So for example, here the packet or the information, the letter wants to go from 1111 to 2221. If I mention in the firewall saying that 1110 to 2220 means anybody from 1.1.1.0 network, anybody from 2. Network is allowed. Only then the packet will be allowed, or the information will be allowed to pass through it and reach the destination. It is kind of a toll gate. In the highway, you would have seen a toll gate, right? Of course, if you pay, everybody is allowed. But understand the toll gate, or imagine the toll gate as a checkpoint where they allow only certain vehicles and certain they don't, depending upon the rules that they have. Let's say they have a ledger, in that they have certain rules. Even firewall creates a rule table for itself, right? It has a different rule table. It will refer to the rule table. Whenever an information comes and hits on the firewall, it will check. This is the source, this is the destination. Are they allowed to go? Are they allowed to communicate with each other? It will check the rule table. Based on that, the information is either allowed or discarded, or it is blocked. So that is the primary function why we use, yes, definitely. Router also can do that. Switch also can do that. If I want, I can go to the switch and block certain access from 1111 to 1113. I can block it. In the switch also, I can create something. There are some configurations which you will be, by the end of CCNA, you will be thorough with those configurations, I'm sure. You can also create that. Why do we need firewall? Because switch function should be done by the switch. So for example, if the switch does the switching function also, routing function also, firewall function also, then I would need a higher end switch with a higher cost, higher memory, higher CPU, everything higher. If I ask it to do all the functions, so if I ask you to read every department book, then of course you need, you need more time. There will be delay, right? More resources you need. Similarly, a switch as well. I can do that on a switch as well, but not every function of a firewall that a switch can do. Not at all. Basic allowing and denying traffic, yes, it can do. But firewall has more functions than the router and a switch, where it can inspect in the sense it can go inside this information, check what is the information, is it legal information, legitimate. It can encrypt, decrypt the traffic. Let's leave about encrypt, decrypt. It can actually go inside the information, check if it is a legal information, pattern, what is the pattern of it, and then decide if it has to be allowed or not. So basically, I would say firewall as a device has more advantage and more advanced functions than these devices. That's the reason we use firewall as well. And the most, the most prior reason to use the firewall is not because that we always want to restrict some traffic. No, we don't do it internally inside our own organization. Let's say this is all our routers and switches. We don't suspect these devices because I know I configured them. We suspect the outsiders who are trying to enter our organization, right? Maybe this switch is connected to some servers. Okay, Flipkart server and all, right? Flipkart, Amazon, you have some clothing, gadget, all these are in this server. Usually people actually get inside this server to see what is the price of so and so. Now, when they actually go inside, they come inside our organization in a separate zone, I would say. Now, also the attackers also can do the same thing, right? They are jealous of our own servers, so they can send, 20,000 requests to this server. This server only has, 10,000 request capacity. They can send 20 to 30,000 requests and make this server not functioning. So outside to the public world says, okay, Flipkart server or Amazon server, it is not responding all the time. It is, busy all the time. Whenever I see, it is not working. So they move to the different vendor, Meesho, whatever, different e-cart. So this is also one type of attack. So this is not only the, one type of attack, I would say. There are many like this. There are many things on the internet that can happen to make your internal organization, server, or anything function in an improper way. They can make that. So that is the reason we install a firewall. Not because of we are scared of our own devices. No, we are not worried about our internal. Sometimes, yes, we do also have internal access blocked as well from HR to IT. Not everything is allowed, right? But usually the eye is on the outside world where there are attackers. That's the use of a firewall, I would say. So these are some of the main components, or I would say the main devices in the network, right? And similar to this, we have access points. This is another networking device. What is an access point? So for example, this is your Wi-Fi router. This is your Wi-Fi router at home. You have some ports on it, right? This is your Wi-Fi router. Now we call it as a Wi-Fi router, but it does the job of a router, a switch, and an access point. All the three. It is a 3-in-1. Okay. Now, why a router? Why does it do a job of a router? Because on the other end, it is connected to either Vodafone or Airtel or Amazon. AT&T, Vodafone, Verizon, the other service provider router. It is acting as our edge router, which can route our network information to the outside world. It is acting as a router. Why it is acting as a switch? Because we are allowed to connect our computers through cables to these ports. Why it is acting as an access point? Because if you have a laptop, it can also send radio waves through which the wireless devices can communicate with each other. So access point is nothing but same as a switch. It is same as a switch. So for example, this is a switch to have computers connected to it, right? This is a switch. Whereas access point is the same as a switch, but it connects different laptops with the help of its waves, radio waves. It is wirelessly connected through all these laptops. Then it is connected to a actual switch with the help of a cable, right? Or let's connect this one to this one. It is connected. So basically any wireless network on the upstream, I would say upstream, is connected to a wired network. It is connected to a wired network, but these are wireless devices, right? It connects to so access point is a device which acts as a bridge between the wired network and the wireless network. Right? And we will talk about it. So how does it, connect to different PCs, different laptops? Does it use, you said it is in the form of radio waves. Now, what is the frequency of the radio waves? What does it use? Everything we'll learn about it in the wireless section. Okay, how it connects, how it is made to connect, and whenever they are sending any particular radio waves, how does this PC identify that this radio waves only has the information that I require? How does it know? Everything we will be looking into in a deeper way during our wireless classes or sessions, right? For now, you have to
Yes, just
understand
today
that.
is just an introduction about all the network devices, and from next weekend, from very basic, we are gonna start our day one. So as of now, so guys, anybody have any questions related to what we discussed today?
नो सर।
Thank you.
यार सर एक क्वेश्चन पूछना था। राहुल मिश्रा बोल रहा था सर।
हाँ, पूछिए।
सर ये बोल रहा था कि जैसे क्लासेस जैसे आज पूरी थ्रू आउट इंग्लिश में हुई तो मुझे समझ में तो आ गई, पर जैसे हम लोग हिंदी में क्वेश्चन पूछना चाहते हैं तो पूछ सकते हैं क्या? और जो
डेफिनेटली पूछ
स्टडी।
सकते हैं। तो मैं थोड़ा थोड़ा हिंदी मैनेज कर लेता हूँ, जैसे अभी बात कर रहा हूँ, थोड़ा 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 मैनेज कर लेता हूँ,
जी सर,
पर
जी सर।
बहुत सारा टेक्निकल मैं मैनेज नहीं कर पाता।
हाँ सर, मतलब जैसे मैं कुछ चीजें कम्युनिकेट करने के दौरान, मतलब हम लोग टेक्निकल जो वर्ड्स होते हैं वो तो इंग्लिश में यूज करते हैं, पर जो मतलब कन्वर्सेशन जो बीच में होता है उसमें हिंदी में कर सकते हैं।
हाँ हाँ, डेफिनेटली।
और सर ये पूछ रहा था सर, स्टडी का जो मटेरियल रहता है वो मतलब हिंदी में मिलेगा कि पूरा इंग्लिश में मिलेगा सर?
इंग्लिश में ही
इंग्लिश
मिलेगा।
में ओवरऑल सारा।
ठीक है सर, ओके सर, ओके सर, थैंक यू सर।
ठीक
और एक
है।
क्वेश्चन था, मतलब ये वीडियो लेक्चर मिल जाएगा?
सॉरी सर, आपका आवाज क्लियर नहीं आ रहा है।
मतलब वीडियो लेक्चर्स मिल जाएगा ना, थोड़ा नेटवर्क इश्यू था मेरा।
एग्जैक्टली ईच एंड एवरी सेशन इज रिकॉर्डेड। जैसे आज सेशन करेंगे तो आपका अगले 3-4 घंटे में वो सेशन का रिकॉर्डिंग आपके पोर्टल में अपलोड हो जाता है, सो दैट यू कैन रिवाइज बिफोर कमिंग टू द नेक्स्ट क्लास।
ओके, थैंक यू सर।
सर क्लासेस कब से स्टार्ट होंगी सर?
आज इंट्रोडक्शन था। फ्रॉम नेक्स्ट वीकेंड वी हैव अ प्रॉपर 2 आवर्स क्लास।
ओके सर। सर ये वीकेंड बैच होगा सर, सैटरडे संडे?
हाँ, ये दिस इज गोइंग टू बी अ वीकेंड बैच, एंड वीकडेज पे बैच आ रहा है, दैट इज फ्रॉम 27th of March। हिंदी वाला बैच है, मंडे टू
ओके
फ्राइडे
सर,
9 PM।
ओके सर, ओके सर, थैंक यू सर।
सर इस बैच का टाइमिंग क्या है?
इस बैच का जो टाइमिंग है, बस ये नेक्स्ट वीक हम ये 11 बजे करेंगे, उसके बाद हम 10 o'clock कर देंगे, क्योंकि बस राहुल का एक लास्ट सेशन बच गया है, तो कुछ प्रीवियस बैच का वो कंप्लीट करके 10 to 12 करा करेंगे। पर अगले सैटरडे संडे 11 o'clock ही है।
ओके
Sir, can we attend the Hindi classes also along with this?
See, this is something that you need to discuss with your counselor, but it's not possible because
Oh, yeah.
somehow you are getting a lot of confusion because you're learning from two different trainers, and the pattern is something different what they are following.
Correct, correct.
Okay.
And where is the study material attached, or in which website it is available?
The material and all, you can directly go on nwkings.com. You're able to see that, and on ott.nwkings.com you're able to join a live classes and replay. We have a recording on the replay portal. That all the information you'll get it by today evening only through our support team.
Sure, sure, sir. Thank you.
सर ये बोल रहा था कि जैसे नेटवर्क किंग्स की कोई जो ऑफिशियल वेबसाइट है उसका यूआरएल बोल रहा हूँ सर, यूजर नेम और पासवर्ड वगैरह हमको मिलेगा क्या स्टडी मटेरियल एक्सेस करने के लिए?
हाँ हाँ, सब कुछ मिलेगा भाई मेरे, वो सब कुछ उसके अंदर मिलेगा। आपका अकाउंट अभी आपने अभी ज्वाइन करा है तो अभी आज एक अपने ओपन लिंक से ज्वाइन किया, ठीक है। पर
जी सर।
आपकी जो क्लासेस होंगी वो अगले सैटरडे संडे से वो बिल्कुल सिक्योर होंगे। आपको पोर्टल से ज्वाइन करना है, यूजर आईडी पासवर्ड डाल के ही।
चलो, हो गया।
ओके सर, ओके सर।
Do we have a session tomorrow?
No, not tomorrow, from next weekend.
Okay, and that will be in the portal, right? OTT.
Exactly. Right, sir. You're right, right. So
Okay,
let
so
me show you
are
how
we
this
done for
OTT
today, or
Sorry?
are we done for today, or?
Yeah, we